discuss about how to calculate the bill. Bill means electricity bill. You know, when we pay the bill, electricity bill, okay, the unit which is used for calculating the amount of electricity consumed in a given time interval is kilowatt hour. Kilowatt hour is also called kilovolt ampere hour. If you observe the electric meter installed in your house, you will come to know about that kVAH. kVAH means kilovolt ampere hour, which is other word for kilowatt hour. Okay, we don't express the unit in joules because electricity is also a type of energy. If you want to calculate it in joules, the number will be very big. So we take a higher unit, that is the commercial unit of electric energy, which is kilowatt hour. Okay, so let us find out how to calculate the bill. Bill calculation of electricity. Okay, I'll discuss you some steps which involve how to calculate the bill. Okay, so first of all, we shall calculate the electric energy consumed in kilowatt hour. Okay, this electricity consumed in kilowatt hour is on daily basis. That means it is the amount of electric energy you consume in one day. Okay, so this is the daily consumption. Okay, now the formula for this is you have to express the power, that means the electrical power in watts multiplied by time, that is in hours, divide the whole by 1000, right? Why 1000? Because power in watts divided by 1000 becomes power in kilowatt hour. This could be also expressed as power in kilowatt multiplied by time in hours. This is how the unit comes, kilowatt hour. That is the commercial unit of electric energy. Okay, this is step 1. Okay, now in step 2, you have to find the total units consumed in a particular period of time. Like you are paying monthly. Okay, so in 1 month how many units the electric meter has recorded, that you want to know. Okay, for step 2 we have the total units, right? This is equals to daily units that is this amount of units consumed in one day multiplied by number of days. Okay, suppose if you are consuming for 7 days, then it will be 7 days, that is weekly bill. Suppose if it is monthly bill, then multiply by 30. Okay, now step 3, that is the total cost. This is equals to total units multiplied by the rate per unit. Okay, that means every electricity board, okay, that has a particular rate specification, like per unit what they are going to charge, that is the rate per unit. 1 unit means 1 kilowatt hour. Okay, we speak 1 unit because this is the units consumed recorded by electric meter. All of us know there is an electric meter installed in our house. So if you record the units consumed, how to record the units? The person who comes to record the bill, he writes the previous reading. Suppose the previous reading is 400. Okay, and then after 1 month when he comes, he records suppose 800 units. So the difference, that is 800 minus 400 gives you 400 units. For this, the bill is going to be charged. Right now, you are calculating mathematically, okay? That is only possible when the person comes to record, okay? So, the three steps for recording the bill calculation is, first of all, you have to calculate the electric energy in kilowatt hour, daily basis, per day, that is power in watts into time in hours divided by 1000. We divide by 1000 because this is the conversion for power in watts into power in kilowatts. Suppose you are getting power in kilowatts, like heavy appliances, geyser, then air conditioner. So for that, the power in kilowatt will be multiplied directly time in hours. This is per day run time. That means how many hours you are using that appliance for a particular day. Okay. Then the second step is that you have to get the total units consumed. Multiply the daily units consumed in one day into number of days. Okay. Third, you are coming to total cost. This is equal to total units consumed. Step 2, multiplied by the rate per unit. Okay. Now let's discuss one question. See how the application is made. Okay. Suppose we have an electric heater is made to run for 2 hours daily. Okay. Find the monthly bill if the rate of 1 unit, that means 1 kilowatt hour, costs rupees 5. Okay. So first of all, as per step 1, okay, you are finding the daily units. This is equals to power in watts multiplied by time in hours by 1000. Okay. So the power in watts is given to you. If in this question the electric heater is suppose having the power, suppose if the power of heater is 2000 watts, okay, and is made to run daily 2 hours, and you have to find the monthly bill. So for the step 1, we have daily units, that is power in watts into time in hours by 1000. Suppose the power is 2000 watts multiplied by time in hours, that is 2 hours, divided by 1000. So it comes to 4 units. Okay. Now as per step 2, the total units for 1 month, applying the second step, we have the daily units 4 multiplied by, because you have to find the monthly bill, a month comprising of 30 days, so it comes to 120 units. Okay. Now step 3, the final step, that is you are finding the total cost. What is the bill you are paying in rupees? So total cost, applying this formula, total units we got 120 units multiplied by the rate, that is 5 rupees. Okay. So the answer is rupees 600. So these are the 3-step working, but not always you will be given like this. Suppose the power is not given, okay, and you are given the resistance, current passing through the heater, okay, then what to do? Then you have to calculate the power, okay. So these are the steps for bill calculation. Now a little bit complicated question I am giving you. Hello students. Now we are going to discuss about something, mathematical expressions, formula regarding electric energy. Okay. So we are going to provide the various expressions how to calculate the electric energy. Okay. Now, first of all, this electric energy can be expressed as, suppose we consider this as E. This can be considered as V into I into T. Okay. Here V means the potential difference. Okay. That is expressed in volts. This is the amount of current expressed in amps or ampere, and this is the time in seconds. Okay. So if everything is written as it is, then this energy comes in joules, abbreviated as J. Okay. So our first expression is to calculate electric energy if the voltage, that is potential difference, current, time, all three are given. Okay. Next, the second expression for this electric energy can be expressed as I square R T. Okay. Here the I is current in amperes, R is resistance, that is the obstruction offered on the flow of current, and time period is in seconds. Okay. Third expression, again electric energy can also be expressed as V square by R into T. Okay. See, these depends upon the availabilities of the parameters. Suppose current and resistance, time is given, you can apply this formula. Potential difference, voltage, current, time is given, you can apply this formula. If current is not available, voltage and resistance and time is available, you can use this expression. And the fourth, the last expression is electric energy equals to power into time. Okay. This power is in watts, that is joules per second. Now let's give a quick recap what the symbols mean. V is for the potential difference. And the unit is volts. Okay. Abbreviated as V. And I is the current flowing through the wire, which is in amperes, expressed as A. Then T is the time for the passage of current and amount of energy production. This is in seconds, abbreviated as S. Then we have R, the resistance, expressed in ohms, and the symbol is omega. Then we have the power. This is the electrical power, okay, which is expressed in joule per second or simply watts, abbreviated as W. Then we have the electric energy. This is the electric energy expressed in joules, abbreviated as J. Okay. So this is how you are going to express. Okay. The voltage is there, current is there, time is there, resistance, power, electric energy. Now we are discussing about electrical power. Okay. For this we have the expression, that is electrical power P equals to how much electric energy the appliance is consuming in a given time interval. Okay. So this is the rate of work done as you have done in normal energy chapter, but here we are discussing electrical power. It is the same thing, the rate of work done, that is the amount of electric energy consumed in a given time interval. So we can express this as P equal to energy by time So P equals to E by T. Okay, that means the electric energy what we have written over here, this one. Clear? Also power equals to V into I. Okay, because since it is the rate of work done, so if you divide VIT by T, TT cancels. So V into I, this is the expression. Second expression, right? This is the first expression. Then the third expression is power P equal to V square by R. Okay? Again the same thing. We are removing the expression T from here. So this is the amount of power consumed. Fourth, we can also write power P equals to I square R. Okay? Again from I square RT divided by T, TT cancels, so I square R. Okay? So these are the four expressions for calculating the power. Why I am discussing this? Suppose in case of bill calculation, this is the expression what we use for electric energy in kilowatt hour. Okay, see there's a difference in these two when we are using in kilowatt hour. Okay, automatically the time has to be in hours. So for that we have the expression. This is the fifth expression what we are discussing. And for electric energy in calculation, that is kilowatt hour. This is the commercial unit of electric energy. We have the expression power in watts multiplied by time in hours by 1000. Okay, why? Because this is the conversion of power in watts into kilowatt, so that sometimes we can use this expression also, power in kilowatt multiplied by time in hours. Next, suppose power in watts is given, you can use this first step. Okay, this is suppose equation 1a. Okay, this is equation 2 when power in kilowatts is given and you have to calculate this. So this is the second expression B. Sometimes the power is not mentioned, the current and resistance is given, then you can use I square R. Okay, where I is for current and R is the resistance. So the product of I square R gives you the power in watts multiplied by time in hours. Okay, divided by 1000. Okay, because this expression is in watts. Clear? Also we can use this expression V square by R into time in hours, the whole divided by 1000. Okay, also we can use this expression I square R into T, that is time in hours, divided by 1000. Okay, so these are the possible ways to find the electric energy calculated in time in hours. We are using this simply for energy consumption in joules. But if you want the bill calculation, okay, the commercial unit of electric energy, then the power will be calculated in watts, kilowatts. Okay, or else if these two are not available directly, then these sort of parameters can be used. The symbols have already been discussed over here. Okay, so please be sure about whether you are calculating the electric energy in kilowatt hour. Definitely the time has to be in hours. But suppose you want to calculate simple energy in joules, then definitely the time has to be in seconds. So that's the difference between the two. Okay, this is the normal electric energy in joules and this is the electric energy in kilowatt hour. Okay, so if you practice the question, you will come across while calculating the bill, these possibilities could be checked out. Okay, so you are using 5 expectations that these are the 5 expressions you might come across. Okay, and after calculating in one day, you can calculate for number of days and then the rate. Okay.